Hi, I am M. Kamakshaya. I am open source software evangelist and also an academic. I am a freelance trainer of data science and analytics. I often create a few applications using Python, R, and quite a few other programming languages. I am expert of R and Python, and I use these two tools together with some other few other tools to teach and provide training in data science and analytics. I created a small web application for machine learning algorithms. I used R programming language to create a web application to practice different algorithms available from the area of machine learning. And this is my GitHub page. You'll find the address here. Just have to go to the https://github.com/Kamaksha, something like that. This I will try to update in my video description. Once you go to this URL, just go to the repositories, and where you will find all my repos. And this is the web application which I am talking right now in this video cast is named as MLtRS, which stands for machine learning through R Shiny. Just have to click on this, and right now there are very few files. You just have to find a file with the name MLtRS.R. This is actually the source code, or alternatively you can just go here and download the zip. You can save somewhere in your computer, but you just have to go to the place where you save the files, and there you will find this .r file, this one, and you just have to click, and you should install R as well as RStudio in your computer. And there are also a couple of dependencies which you need to install well before starting this application. And those dependencies, once you right click on this, if you had installed, by the way, I'm using Ubuntu 18.04 for my work, and this can be used on all operating systems as long as you if you can provide R and RStudio in your computer. When you double click on that, there will be an option in Ubuntu. Even in Windows it should be like this, open with RStudio, something like this. So press on this, and then you will be taken to RStudio editor. This is RStudio editor. Perhaps you will have this is how it looks like, and not even like this, but when you start it would be something. So once you open this, your file appears here. This is MLtRS.R something, the same file which I have shown you in the file system. And now you'll find a small run button at the right side of the top left window panel, and there you will see run app, something like this. You just have to press on this link, and then your application will be started in RStudio web browser. Suppose if you want to start this application, this is for testing. For practice, you just have to choose this button, open in browser, something like that. Now your application goes to your default web browser in your operating system. So this is actually the launching page. I call it as a home button, and there are a couple of menus for your practice. And by the way, this is right now in development, and it is very much useful for testing. Suppose if you are watching this video, you must have already started learning machine learning algorithms. This web application is very much useful in order to test the algorithms with demo datasets. So by the way, I provided few datasets for practice in my repository. They all belongs to healthcare domain, which means they deal with different health problems, just like heart problems related to heart, problems related to skin, problems related to organs like prostate, and also diseases like diabetes, sepsis, something like that. You can and now once you open this menu, is useful to import the data sets, and once you import the data sets, you have a menu for statistical analysis. You can just perform all that univariate, bivariate data analysis here, and then straight away go for. By the way, in machine learning we have two categories for practice. There are methods segregated under supervised learning, and there are methods segregated unsupervised learning. Right now, under supervised learning, I could provide this classification techniques. There is logistic regression, nearest neighborhood, support vector machine, decision trees, random forests, naive classifier, neural networks. And under unsupervised learning, I have PCA. I think I don't have factor analysis. So in future development, I'll be able to provide a few more algorithms here. There is a provision for the Gaussian mixture modeling, and there is also a technique called novelty and outlier detection. By the way, all these techniques require few packages that need to be installed in your RStudio. And there is also a menu for clustering, but this clustering is not k-means or hierarchical. This technique follows a particular algorithm called fuzzy C-means clustering, something like. This manifold learning MDS. This is actually multidimensional scaling. Right now, the app is not in a position to support this technique, but I should be able to update the methods for all this. But all the methods listed under supervised learning are good to go. But few of the methods under unsupervised learning are able to you can practice few of the methods listed under supervised learning, but one or two methods right now there. But anyway, there's not a problem for testing. And now let me show you how to test few data sets. I mean, to predict disease. So I'm going to show how to predict the disease by using few data sets. I'm going to upload or import the data set. So to import the data set, you should just have to go to your file system and pick up the data. I have few demonstration data sets here. The very first data set, this is a log or SVM. This data set is related to some certain health problem. So this is actually the survey data from the patients. I don't know how many patients are there. Maybe anyway, I have a provision for. You can just go to the statistical analysis, and there you can find length. Okay, you can just take one of the 303. You can go for the dim. Dim is not okay. Anyway, for timing, you can just go for 303. There are three. This data represents 303 patients, and this data describes health attack, something like that. There is age. The details related to age of the patient, sex, which means gender. 0 stands for female, 1 stands for male, something like that. And there are quite a few other variables. This is actually the most important variable with a name num. It is actually a categorical variable. By the way, in machine learning, the dependent variable need to be a categorical variable, but it should be numerical. Here 0 represents that this particular patient with these details is not suffering from the heart attack or something like that. And here there is a patient with all these details, and he is actually a patient. He is suffering from the health problem, heart problem. And here there are certain technical data. This CHOL is a cholesterol and something like this. And if you are a medic, I think it is very easy for you to understand all this data given some certain details, just like this. And this is actually the entire data set, the historical data of 303 patients, and now we are going to predict. We're not exactly going to predict. What I'm going to do is that in machine learning we need to have two different data sets, one for testing, the other for one for training, the other one for testing. The testing data is always a new incoming data, and the training data is some certain historical data with patient details. We feed this training data to the algorithm, and the algorithm learn what is happening in the data. And now we have to tell the algorithm which one is the dependent variable, which one is the response variable, which are the predicting or predictor variables, predictors, and this is a response variable. These are predictors, and I am going to, since this is testing app, this is an application which can be used for testing. I follow a particular discipline, like dividing the entire dataset into 80:20, which means 80% for training, 20% for testing, something like that. So same dataset is used for both training and testing, and we are just going to evaluate if a particular algorithm is able to explain the prediction. A particular algorithm is suitable for prediction or not. So now to start with, I'm going to use SVM, which stands for support vector machines. And if you don't know anything about SVM, here I provided a link for your ready reference. You just have to click on this link and you'll be directed to a Wikipedia page where you can read. This is actually ML Wiki. Here there are methods for logistic regression. These are actually so you need to know what exactly logistic regression is. Even for if you already know what is logistic regression, then only you will be, so you should be in a position to judge that logistic. If you feel that logistic regression is really a good, if you think that logistic regression is going to solve your problems of prediction, you can straight away go here. And I'm going to use I'm talking about support vector machines. I'm going to use support. So I need to choose my categorical variable here, which is response variable or dependent variable. So here it denotes the proportion. I want the entire data should be divided into 80:20, which means 80% of the data for training and 20% of the data for testing. And you just don't care about this class variable right now. And the very first button is the show proportion, which means what are the dimensions of my training data and dimensions of my testing data. For training data, I have 243 rows and 14 columns, and to test the algorithm, I have tested data with 60 rows and 14 columns, something like that. Now I'm going to request the fit, which means some important statistics related to this particular algorithm. So this algorithm has gone through training. This algorithm trained, and now it has acquired some learning, and these are actually the statistics that represents the amount of learning that happened through this algorithm. Now accuracy is only 0.53, which is not so good. This particular algorithm is not able to learn anything from the data, and there is a statistic known as kappa. This is very important statistic in classification problems, especially we most of the time talk about kappa. This is also called Cohen's kappa, as a statistic which demonstrates the agreement between two different judgments. Suppose if you have two different issues in your data, and what is the agreement? It is something like a relationship kind of thing. So here there is a very poor relationship between two different categories, and so this again is in agreement with the accuracy statistic. Now let's go to the predicted values, and it will show you these are the actually the predicted values by using the test data. So I told you that there are 60 items in test data, and you see 1 0 1 0 0 something like this. And now let's go for the predicted. You should imagine that actually these predicted values are something, the outcome from the learning of the algorithm. Imagine that we have given some new data with 60 rows with all new information, and now we don't know what is the position of the patient. Now in our test data, the very first patient, it is likely that he is suffering from the heart problem, and second patient, with all his information, it seems that he is not suffering from the heart problem, something like this. So there are zeros and ones here, but this way, this is useful for medicos or healthcare consultants or doctors to given some patient information, how likely that a particular patient is going to suffer from the heart problem, something. But for us, for testing, the people who are in academics and research, what they need to do, they just have to go for the accuracy measures. And here you have a confusion matrix, and if you'll see, we have 50% of accuracy. You see, this diagonal values should be maximum, and this values should be minimum. This is actually called, I will take you the confusion matrix. Wikipedia is just sufficient. You don't need to worry about, don't buy and read costly books, just don't have to. In confusion matrix, what happens is that you have true positives at the upper right corner of the, like suppose if you see here, let me take you back to, here I have, this is upper left corner of the, this is a cell, the cell which is upper left corner is a cell which belongs to a particular observation called true positives. So these are actually, a patient is suffering from a heart problem, and the algorithm predicts that he is suffering from heart. That is what is the meaning of true positive. And now the another important cell is the bottom right corner cell, which stands for the false negative. Sorry, I should say false. No, false. No, it is true negative. True negative. This is actually a true negative. This is true positive, and this is true negative. So these are the two responses. The algorithm must be able to pick up the values such a way that these two cells are filled with maximum numbers, and these two cells should be filled with it should be 0. So there must be true positive, and there must be true negative, and this is actually true positive, true negative, and this is false negative. So that is it. So this is a confusion matrix. Read more here. So we just have to come here. Let us pick up the totals here. In true positive, true negative, we have 30. Sorry, I'm confusing myself. True positive, true negative, false positive, false negative. Okay. True positive, true negative, false positive, false negative. So there are 30. This diagonal has 30, and this diagonal has 30. So that is why we have an accuracy of 50-50. So this algorithm is not that trustworthy. So suppose if we take any decision on these predicted values, it is 50. It is just like 50-50 kind of situation. It is 50% likely that this patient is really suffering from heart attack, and 50% it is unlikely that. So that is now the decision is in the hands of the the doctor, whether he need to consider this particular algorithm for decision making or not. Now in the same fashion, the same dataset I can also use for logistic regression. Here again I will take the, and let us see whether if the logistic regression can improve the prediction or not. Now this show propositions, this algorithm also I'm using 80% of the data to train the algorithm and 20% of the data to test the algorithm. And now I'm going to request the fit. Yeah, RMSE is 0.5, that is not good thing, and the R-squared value is very poor, it should be close to 0, and the MAE value, mean absolute error, is also high as RMS is. I don't think logistic regression. So there is some noise in the data as I now infer. And now these are the coefficients. These coefficients are known as the e to the power of beta, and these are called the odds ratio. These are the odds ratios for each of the you have a lot of information online as how to interpret this data. Just like suppose if I have two categories in as we know that there are 0, 1. So how likely that a patient is suffering from the heart attack when we move from 0 to 1, something from no to S. So here it is almost 0. So something like this. It is highly unlikely that a patient is suffering. Suppose if I move, it is almost like 1 point. So if I move one category from lower to upper, then it is for every one category jump in age can jump from no to S, something like that. So in all categories, it is when the patients move from one category to the other category in number in the sense like outcome. Patients suffering from heart attack, yes. Patients suffering from heart attack, no. So from no to S, when we move from one category to the next category, it is highly likely that the patient must be suffering from the heart attack. So there is a perfect correlation between the levels of the age versus the levels of the heart attack or something like that. Now let's go for the let's pick up some few negative. It's not negative actually, 0. Suppose let's take some technical cholesterol. This is actually 1, right? So now it makes some intuition to us, like if the cholesterol level increases from one level to the other level, suppose if I say 1, 2, 3, 4, there are 4 levels. When we move from level 1 to level 2, it is likely that the patient suffers. The probability of patient suffering from the heart attack is also high. So this is how we can make some sense from this training. Now let's go for the prediction accuracy. So here, yeah, of course we have same 50% of the accuracy, means we have almost the same level of numbers in diagonals of this matrix. The kappa value is negative, which means we cannot strictly believe in this algorithm. So the algorithm hardly learned anything from the data. So it is up to the healthcare consultant or doctor to take the risk. So this way maybe we can change the data might be insufficient for training, so we need to change the data and see if the algorithm improves by chance next time when we change the data, something like that. So this way we can just go ahead, and I'll just try to describe the decision trees, and then because decision trees are very, very important technique in supervised learning, and for that I have a data set here. What is the data set? Breast cancer. Very good. So now this is actually the information related to the breast cancer. I have information of the patients related to age, menopause condition, tumor size, something like that, number of nodes, and the last one is actually the categorical data. The very first patient is suffering from the breast cancer, and this is the information for all these variables. And patient number 2 is not suffering from the breast cancer, and you see here the information is different for the node caps. and they're all actually monopaths. There is some coding here, something like this. It just can go here. Breast quad is a variable, and there are some certain responses, and there is a difference between these two. Maybe if the patient is with this category for these two variables, she or he, but we cannot come to such fastidious conclusions. We have to hand over this data to the algorithm and see what algorithm is trying to predict. And now I need to choose the categorical variable here. Now let me go for the table. Here there are 201 patients, and there are 85. I think there are 201 patients who are not suffering from the breast cancer. There are 85 patients in this data who are suffering from the breast cancer, something like that. And now show propositions. Yes, of course, 80% of the data is being. You can just change this 80%, but you need to know how to do changes in the R program. So I don't suggest to, because 80 versus 20 is always a good procedure while performing machine learning analysis in using machine learning. Now train versus test data. This is how this data is used for. This is only the first 6 records of the training data, and this is first 6 records of the. Now you can see there are 228 rows in training data, only 58 rows in testing data. Now let's straight away go for the fit. We don't get anything, we hardly get any information from the fit. And let's go for the summary. Of course, here you have some important. There is MSE, mean squared error, that is 500. Oh my god. Importance 20, proximity. So this is not going to help us. Now let's go to the predicted. Yeah, of course, this is a bit useful, but you see, ironically, the predicted value should be either 0 or 1, right? We cannot have 0.01. Now suppose if you have 0.01, it simply means that it is 0 and 0.9 is 1, something like that. So this way you can just now let's go for the accuracy. These are the predicted values which the doctors can make use of while predicting predicting the breast cancer for patient number 229. This is the test data, which is new incoming data supplied to the algorithm. So we train the algorithm when we press the fit, this button fit, and now these are the predictions. Algorithm has learned something from the data. Now it predicted. So when we press the predicted, we'll get the algorithm predicts the data, and then by using the data and then eject some output. Now you see 229 patient 229. We have to go back and see what are the properties of the patient, and it is unlikely that this patient is suffering from breast cancer. But patients 230, it is highly likely that they are suffering from the. So we just have to. This is how we can predict the incidence of breast cancer by using data. Now let's go for academics and testing. You can just go for the accuracy, where you will get the confusion matrix. Oh, mind blowing! This decision tree, I think we use decision tree, right? Decision tree is a beautiful algorithm which and fortunately we don't even have noise in the data. You see the left top corner, bottom right corner is filled with numbers, and here you see zeros in the other diagonal. Now these are the true positives and these are the false positive. So I think I again forgot this. True positive, true negative. I'm sorry. True positive, true negative. So the algorithm, if something is positive, then it predicts that it is positive. It means that a true positive is a case where the algorithm predicts the probability of suffering from the breast cancer when the patient is really suffering from the breast cancer. And a true negative is a case where the algorithm predicts that the patient is not suffering from the breast cancer, and in reality the patient is also not suffering from the breast cancer, something like this. And now that is why accuracy is close to 1, and this algorithm really learned a lot from the data, and the doctors can make use of this algorithm to predict the breast cancer. given some certain data like this. This is how this application can be used for testing machine learning algorithms for both academic and industry practices. Hope this video can give some insights into machine learning algorithms and how to use this web application. If you like my video, please press like and stay tuned for the new content, and write to my email ID or try to contact me for any customized needs, training or consultancy. Thanks a lot for watching this video.